You know that feeling when you're staring at a spreadsheet and it's so messy, it just gives you a headache? Yeah, we've all been there. Well, it turns out there's a really powerful, formal method for cleaning up all that chaos. It's called database normalization. And honestly, it's the hidden art that makes our digital world run smoothly. So let's pull back the curtain and see how we can bring some serious order to that chaos. Okay, so take a look at this. It's a spreadsheet from a car dealership. At first glance, you might think, seems okay, but look closer. Look at our customer, Hans Meyer. He's bought two cars, right? So we have two car makes, two serial numbers, two salespeople, and two different dates, all crammed into the same cells. It is a complete mess. Does this look a little familiar? The thing is, this kind of setup isn't just clunky or inconvenient. No, it's actually a ticking time bomb. It is a minefield for data errors that can cause huge problems down the line. And these problems, they actually have names. So let's talk about the real hidden cost of a mess like this. Because these aren't just what-ifs. These are specific, dangerous problems that people who work with data call anomalies. First step is what's called the update anomaly. So imagine Hans Meyer moves to a new house. You might remember to update his address on the line for his VW Golf purchase. But what if you forget to change it on the line for his Opel Kadett? Uh-oh. Now your database has two different addresses for the exact same person. Your data is officially inconsistent, and you just can't trust it anymore. Then you've got the delete anomaly. See that unsold car at the bottom of the list? That line is the only record we have for the salesperson named Schenk. If we delete that row, just to clean up our inventory list, we don't just lose the car's data. We completely erase any trace that Schenk even works for us. Poof, he's gone from the records. That's a costly mistake. And finally, the insert anomaly. Okay, so what if we hire a brand new salesperson? Where do we add their name? With this structure, there's nowhere to put them. We literally can't add them to the database until they've sold a car. We're forced to either wait, or even worse, create a fake sales record, which is just asking for a whole new world of trouble. So how in the world do we fix this? Well, the solution is a process called normalization. You can think of it like a professional organizer, like Marie Kondo, but for your data. It's a series of steps that cleans up the mess and, more importantly, prevents those dangerous anomalies from ever happening in the first place. So here's the core idea. Normalization is this formal, step-by-step process that you use when you're designing databases. Its entire reason for existing is to structure data in a way that avoids repeating information, what we call redundancy, and by doing that, it gets rid of those update, delete, and insert anomalies we just talked about. It's all about designing for data integrity right from the very start. Right, so why do we even do this? What's the point? Well, we normalize to prevent those crazy data inconsistencies, which is just huge, but it also saves a ton of storage space. It makes sure we don't accidentally lose critical information. And at the end of the day, it creates a stable, flexible data structure that we can actually build on in the future without it all falling apart. Okay, let's start the cleanup. The very first step on this journey is called first normal form, or 1F for short. I like to think of it like tidying a really messy room. This is the stage where you take everything that's crammed into drawers and boxes and you just lay it all out on the floor. That way, you can see every single individual item you're dealing with. So, to get our data into first normal form, we follow three pretty simple rules. First, we atomize attributes. That's just a fancy way of saying we split a column, like customer name, into two separate columns, first name and last name. Second, we tackle those cells with multiple values. Every single purchase gets its own separate row. No more cramming things together. And third, we give everything unique IDs so we can tell every single record apart, no question. And voila, here's the result. Our table is now officially in first normal form. See that? Every single purchase has its own dedicated row. Hans Meyer's two car purchases are now two distinct records. We've also added IDs for the customers, the cars, and the salespeople. It's way more structured. But hang on, we've solved one problem, but we've made another one glaringly obvious, haven't we? Just look at all that repeated information. A massive amount of redundancy. Hans Meyer's name and his address are repeated. We're definitely not storing information efficiently, and you know what? We're still at risk for some of those anomalies. This means we are not done yet. So let's move on to the next stage. This is where it gets really interesting. We're moving on to second normal form, or 2NF. Now, if 1NF was about getting everything out on the floor,
2NF is about creating separate, dedicated shelves for each category of item. You know, one shelf just for customers, one just for cars, and so on.
Okay, the formal definition here can sound a little intimidating, but the core idea is pretty simple. It means that every piece of information in a row should describe the entire thing that row is about, not just a part of it. For example, the customer's name, Hans Meyer, describes the customer, right? It doesn't describe the specific car he bought or the sale itself. So when data only describes part of the record's main identity, well, that violates second normal form. So how do we fix it? We split things up into logical tables. And here's our first one, a brand new customer table. It only contains information that describes a customer, their ID, name, and address. Everything is in one neat, logical place. Now, if a customer moves, we only have to update it right here in one single spot. Update anomaly? Solved. We do the exact same thing for the cars. Here's our car table. It only contains information directly related to a car. Its ID, its make, its model, and its serial number. Clean, simple, makes perfect sense. And, of course, one more for our salespeople. The salesperson table just holds their ID and their name. That's it. And remember that insert anomaly? Well, we can now add a new salesperson right here without needing them to have made a sale first. So, insert anomaly, solved. So, what's left of our original, giant, messy table? Just this, the sales table. It has now become a simple linking table. All it has are the IDs for the customer, the car, and the salesperson for each transaction, plus the date it happened. It's basically the glue that connects our neatly organized shelves of data together. We are almost done, I promise. The final step in this process is called third normal form, or 3NF. Think of this as the final polish. It's about catching some of the more subtle organization problems to make sure every single piece of information is on exactly the right shelf and only that shelf. In simple terms, what this step does is it ensures that a piece of information in a table doesn't depend on another piece of information in that same table that isn't the main ID. Everything should point directly back to that primary key, with no little side trips. We're trying to eliminate something that has a fancy name, transitive dependencies. And here's a really great way to think about it. Imagine in our customer table, the city was actually determined by the zip code. The city doesn't depend directly on the customer ID, right? It depends on the zip code, which then depends on the customer ID. That's a transitive dependency. It's like a chain reaction. Third normal form tells us to break that chain by creating a new, separate table just for zip codes and their corresponding cities. This makes sure every column depends directly on the primary key and nothing else. So we've gone on quite a journey, haven't we? From a totally chaotic spreadsheet to a beautiful set of clean, organized, interconnected tables. We've moved from total chaos to complete clarity. And this isn't just some abstract technical exercise. This is the absolute foundation of reliable, scalable software. Now, of course, this kind of elegance can sometimes come with a performance trade-off, but for most applications out there, data integrity is king. And that really brings us to the final thought. Every time you use an app on your phone that just works, whether it's an online store, your banking app, or social media, just take a second to think. Underneath that slick, smooth user interface, is it all being powered by this hidden, elegant art of data organization? Well, chances are the answer is a big yes.